Hi, Linus. So this is an example that's based on the work energy theorem and also the conservation of mechanical energy along with conservative and non-conservative forces. But we are focusing mainly on the use of the equation for a non-conservative force. Okay, so let's read question. Let's read this question. It said that Tabitha, a cyclist, freewheels without pedaling at a constant speed of 10 meters per second on a horizontal level road. She reaches the bottom of a ramp, incline position A. So she reaches this part here, this part, with a height of 1.2 meters and a length of 8 meters, shown in the figure. While she freewheels up the ramp, she experiences a frictional force of 18 newtons. The total mass of Tabitha in her bicycle is 55 kilograms. And remember, we are told that she was riding at a constant velocity, speed of 10 meters per second on the horizontal road. So if she was riding at 10 meters per second all along while she was traveling horizontally, that means at this point, when she started to climb up the ramp, she was riding at 10 meters per second. That is, V initial will be 10 meters per second there. We also know that her mass is equal to 55 kilograms, as we are told. We also know that this is 8 meters, the displacement. Know that h is equal to 1.2 meters. On number 1, they say, explain whether Tabitha's mechanical energy is maintained or not while she moves from position A to position B. Tabitha's mechanical energy is not maintained as she moves from A to B because there is friction. Remember? So we're going to say not maintained. Not maintained. Okay, so it's not maintained because there is friction. Remember, when there is friction, it means that the work done by a conservative force is not equal to 0. If the work done by a conservative force was equal to 0, then there wouldn't be a change in kinetic energy. And that would also mean that there is no work that's being done by friction. So in this case, there is friction, and therefore the work that is done by a non-conservative force, in this case friction, is not equal to 0. And therefore EM is also not equal to 0. Hence we say that the total mechanical energy is not going to change. So now let's do number 2. Here we are told to calculate the kinetic energy of the cyclist position at A. So what we want is the kinetic energy of the cyclist here. So we want EK here. Do we have values for this part here? We do. The equation that we're going to use here is EK is equal to 1 over 2 mv squared. And we know that the speed at A is 10 meters per second, and we know that the kinetic energy at A, in this case, will be found by substituting the velocity or the speed at A. So this cyclist weighs 55, and V at A is equal to 10. So 10 to the power 2 is going to give us 2,750 joules. 2,750 joules. Now let's go to number 3. Number 3, they are saying that we should calculate the kinetic energy of the cyclist at the top of the ramp at position B. So we want EK here now. Okay, we want EK at B. So for us to find EK at B, because we can't simply use the EK equation, we will have to use the equation W and C is equal to delta EM, and this is equal to delta EK plus delta EP, and this is going to be equal to 1 over 2 mv squared final minus 1 over 2 mv squared initial. So this part here is for delta EK, plus the part that I'm about to write now is for delta EP for potential energy. It's mgh final minus mgh initial. And we know that there's only one non-conservative force here, and therefore WNC, which is the work done by a non-conservative force, will be represented by F friction multiplied by the displacement and multiplied by the cosine of the angle between friction and displacement. There is no other force here that's non-conservative. In this part, we only substitute with the contribution of a force that is non-conservative. So let's substitute our values. Might as well start substituting here. We know that friction is given as what? Friction is 18 newtons. We know that the displacement in this case is 8. So in the place of displacement, we're going to put 8 here. And then the angle, friction is always at 180 degrees. It's against the motion. 180 degrees. Then 1 over 2 is 55 for the mass. The final velocity, let's check again. We don't know what the final velocity is, but we do know that this whole parameter here is for delta EK. I mean, we do know this parameter only here is for EK at A. Remember? Okay, wait a bit. Oh, I almost made a mistake. Let me rewrite this way. This is exactly what we are asked to calculate. This is exactly what we are asked to calculate. We are asked to find the kinetic energy on top at B. So this is EK final. And this whole thing here, this one, is EK initial. So we don't have to substitute here. It wouldn't make sense because we are trying to find the value for EK anyway. So we can't be substituting here. Okay, so EK final, which is what we want to calculate, and then 1 over 2 mv squared. We already know that we already know this whole thing here. This is EKA, that is the kinetic energy at the base here in this place. So we found that it was 2,750 joules, right? And then plus mgh final, mass is 50 times by 9.8 multiplied by the height, final height 1.2 meters, minus this whole thing here is going to be 0 because h initially is 0. The height here at the bottom is 0, so the whole thing becomes 0. And then by performing manipulation techniques, we will eventually find that our EK final is going to be equal to, when we use a calculator, 1959.2 joules. So how you got this is that you drop EK as it is, and then you take everything here to the left, and then you add it to this expression. The answer that you get is going to be EK final, but I'm just writing it here as a final answer, and you should be able to do this because it's basic arithmetic. Now let's look at number 4. They're saying that we should calculate the speed of the cyclist at B. The speed of the cyclist at B. For B, we already, let me do this, EK at B is equal to 1 over 2 mv squared at B. So what they want is EK at B. EK at B has been calculated. It's this value here, the EK final, that is EK at B. So we can just put it here, 1959.2, and then 1 over 2 multiplied by 555 VB squared. And therefore, VB is going to be equal to, so what we do here, we cross multiply by 2 to 1 959.6 and you divide by 85, and the answer that you get is 8.44 meters per second. So that's how you do this whole question. If you have questions that you want to ask, or if there's something you don't understand, you're free to write your comment and I will come read it and see if I can attend to your question. And please make sure that you share the video with friends, share it on various social media platforms like WhatsApp and Facebook, and don't forget to ask people to subscribe, and also subscribe too if you find my content informative. I've been Banele. Thank you.